Good afternoon, and welcome to today's American Machinist webinar titled Preparing for Disaster, Using the Cloud Properly to Keep Your Business Running During the Unexpected. My name is Robert Brooks, and I am the editor of American Machinist. This webcast is sponsored today by Quorum. I want to remind all of you that if at any time you experience audio difficulties or have trouble advancing the slides, simply press the F5 key to refresh your webinar console. I also want to encourage all of you to ask questions of our panel. As a question occurs to you, simply type it into the box on the right side of your screen, and we will address as many of these questions as time allows at the end of our presentation. Now let me introduce today's presenters. Larry Lang is the CEO of Quorum. He brings more than 20 years of global business building experience to Quorum. As general manager of the mobility business unit at Cisco Systems, Larry grew Cisco's mobile internet business to several $100 million with rapid profitability growth driven by the infrastructure demands of smartphones. Prior to Cisco, Larry defined product strategy at Ypsilon Networks, leading up to its acquisition by Nokia. Larry received a BS in electrical engineering from Duke University and an MS in operations research from Stanford University. Rob Livingstone is the owner of Rob Livingstone Advisory Proprietary Limited, an independent IT consulting and advisory practice based in Sydney, which provides a highly experienced, tightly integrated advisory and consulting service to companies of all sizes. He is a fellow at the University of Technology, Sydney, where he teaches postgraduate students in the areas of leadership, strategy, and innovation on UTS's flagship Master of Business in Information Technology Management program. Rob has more than 3 decades of managerial experience in the corporate world, the latter half of which as CIO in a number of multinationals, most recently as CIO of Ricoh in Australia. Rob is the author of the book, Navigating Through the Cloud. He also runs the RLA CIO Mentor Program, helping transform IT leaders into resilient, capable, and confident business executives. And now I'll turn it over to our presenters. Rob, the floor is yours.
Good morning, everyone. Over the next 30 minutes, what I'll be doing is covering off some key aspects of the cloud as it relates to manufacturing organizations. And what I'd be starting to do is cover off a real definition of cloud computing, scope of this presentation to get everyone on the same page. I'm going to talk about a hybrid cloud and how a hybrid cloud is the new reality. Touch on cloud in the context of manufacturing industry and touch on systemic versus technical risks, and then talk about disaster recovery from the flip side of could it be your disaster, and paradoxically, could it be your disaster recovery? So the first definition of cloud, which is the most quoted definition, is that of NIST, which is the National Institute of Standards and Technology. Now, this definition is suitably boring, if you will, tends to make non-IT executives doze off to sleep. The one that I really use the most often is the one which I came across with Dave Asbury, the Global VP of Cloud Security Trend Micro, on a podcast session of mine, was forget the technical definition of the cloud, ask your mum what the cloud is, and she'll tell you that it's not on my computer. And that's a very plain English definition of cloud, which for most people are actually able to get their heads around. To try and scope this presentation, what I'll be doing is talking about cloud computing installations which are relating to major instances with complexity, scale, risk, compliance, some element of integration, and not a short-term view. And so that makes it on the harder end of the scale with the implementation of enterprise cloud. So the question I'll be hoping to cover off is helping everyone to gain an understanding of how does this map to your specific cloud initiatives both now and into the future. The COSO organization is an organization that is well known in the insurance industry, and apologize if this particular slide is a little bit small, but we have two axes on this graph, which basically show that when it comes to the implementation of cloud, we have got two dimensions, which is the vertical axis is infrastructure, platform, and software as a service. And on the bottom axis, we have private, hybrid, and public. And basically, when it comes to public cloud computing and software as a service, that's where the largest degree of risk and control considerations come into play. So once again, how does this play to your specific cloud initiatives both now and into the future? I'm going to be focused predominantly on the application software as a service layer, because this is the layer in which you're counting your software as a service vendor to provide most of the multi-tenancy for your data. And also, we hope they have written applications well, and more importantly, in a multi-tenanted cloud environment, you're sharing the database with everyone else. The platform and infrastructure layer are no less critical, but that is something which is a little bit more, slightly easier to do from a engineering perspective, because this software layer is the one which contains most of the complexity, and essentially that contains all your business logic, and when it comes to integration and so on, it makes it a lot more complicated. Hybrid is going to be the dominant form of computing for the enterprise for a whole range of reasons. The typical organization, unless they are a new startup, typically have some legacy systems in one form or another, and not every application is ideally suited to shift to the cloud in the short term. Gartner's quote here with the next 5 years will be predominantly deployed in hybrid mode, I think is being very, very conservative in my experience. Most organizations that are already moving to the cloud are already hybrid at this point. So my reading of the situation is probably closer to 2 years rather than 5. With hybrid, there comes more complexity because there are more elements to coordinate, more elements to orchestrate. And with this complexity, there's multiple factors in there. Managing this ecosystem is not a straightforward exercise. To touch on some of the aspects to be considered for organizations managing a hybrid cloud environment, versioning and software versioning and change control and rollback can become a consideration. Not all software as a service vendors are able to provide appropriate rollback SLAs in terms of time guarantees. Availability, security, different players in the ecosystem may have different security standards at the technical layer. Life expectancy alignments, coordinating the various elements of the roadmap to make sure that the various systems are being retired at the appropriate time in a coordinated manner. Business continuity, of which a subset is the disaster recovery, which is we'll be touching on in a second. Identity management, single sign-on capability across an array of software providers in the cloud makes it a little bit more complicated, and in most instances, what you're doing is you're basically putting your critical identity management passwords and so on out in the public domain through in the cloud, public cloud environment to have this ecosystem to operate effectively. Due diligence, when you're on the procurement side, there's a fair bit to consider in terms of reviewing that each player in the ecosystem is who they say they are. Forensics, e-discovery, legal e-discovery, also the different cloud providers may be in different legal and international jurisdictions. So there is a little bit of complexity in that particular layer. So the first thing I'd like to do is specifically relating to the manufacturing industry. The most important thing is to start off by looking at your business model and business strategy, because whilst the cloud technology is there as a business enabler, unfortunately, the IT industry is very good at focusing on software first and their business strategy second. So I think the key thing is that cloud should not be a default position. Testing any assumptions that integration with your embedded manufacturing systems, for example, SCADA, it may not be easy or low cost. Network latency is clearly consideration when you have some distance between the different data centers, and also 24 by 365 operations on public cloud. How does that sit if you are using any of the cloud in your operational systems in your infrastructure? Availability and uptime is critical in manufacturing if you have a dependency. And as a side issue, co-location typically has a higher uptime than cloud. So existing IT infrastructure may be need to be re-engineered to facilitate that. So for example, do your existing R&D, engineering projects, and so on, integrate well together. DRP, distribution requirements planning, and MRP, and other traditional on-premise applications may be contenders for the cloud, but once again, as with most other applications in the software as a service layer, just be aware of the multi-layer integration, multi-year integration and other costs, because getting into the cloud can be easy, getting out of it can be a little bit more tricky. So I'm going to move on to the issue of risk. Risk is core to the discussion about the cloud, and it's often one of the largest concerns for organizations, citing the reasons not to move to cloud. And the first thing I'd touch on is the issue of systemic risk. Systemic risk is essentially that risk that would jeopardize your entire organization. And typically, it has the ability to fundamentally threaten your entire organization. And to case in point is the finance industry, which incidentally I was at a Chief Financial Officers conference in Australia yesterday, and I presented a similar slide to this, which was a moot point, being finance industry related. That this industry, which is the most regulated and invests heavily in the risk identification, mitigation, and transference, could be the cause of the GFC. And that's a kind of systemic risk effect. So when it comes to the enterprise, one of the issues, especially this relates to larger multi-divisional, larger multinational organizations, is that there are a relatively small number of individuals in the management layer that have got a complete, transparent and objective view of the overall enterprise in sufficient detail. So when it comes to cloud computing, especially in IT, certainly from what I'm seeing is that the issue of systemic risk is not widely talked about. The technical risk side, this is for anyone who's been through any of the information management security certification frameworks. It revolves around the inventorying, categorization and ranking of individual risks, which typically runs along the lines of risk for a specific event equals impact times probabilities plus some sort of risk adjustment. We all probably know from the history books of organizations that certification does not necessarily equal effectiveness of the risk management model. And also the interaction between the risks is where the silent killer occurs, because when you have that planets aligning, or the so-called black swan event, that's where you get the interaction between the risks combining to lead to that systemic risk. So the question I'd like to ask is, could cloud be your disaster? Because the move to a public cloud provider is one of a step of faith to some organizations, because essentially what you have is you have a contract, and you hope that contract is balanced. It's an enforceable contract and allows you some protection from the failings or non-compliance of your particular cloud provider. So one of the fundamentals benefits of public cloud is the removal of IT complexity. It abstracts it away. It takes it away from the end users. But also paradoxically, because of this additional layer of abstraction, it makes it somewhat more difficult to really peer under the covers to find out what latent or hidden risks are provided or may occur in your particular instance of the public cloud. And if you look at some of the major global providers, Google and other major players, to actually do a deep due diligence within their infrastructure or their operations is clearly a challenge. With the smaller providers, that's a little bit easier to do. So some of the common questions that are asked, where is the data located? This is more pertinent if you have international operations, where the international operations may have in their country of operations particular data residency or jurisdictional considerations. Can you get your data back easily? It's often quoted that you hit a button, you can extract your data. One of the other flip sides to that is the software which stay behind if it's at the software as a service level. So what happens if the cloud provider goes out of business? Clearly, it's like an outsourcing arrangement on steroids, as it were, that if they cease to exist, either they cease to trade or are under some sort of legal requirement to shut down for security or any other reason. If your business is critically dependent on them, then all of a sudden you don't have a system. Software escrow arrangements may or may not be a challenge in the cloud ecosystem. Also, transference of risk. If you have on-premise enterprise IT systems, those would be normally covered under most business continuity insurance policies, where you would be able to transfer the risk to your insurer. This is a little bit trickier in the software and public cloud provisioning arrangements. There is some broad assumptions that because you're in the public cloud, that you don't need to worry about disaster recovery, because the provider takes care of all of that for you. But this, in some instances, cannot be assured. In fact, in some of the well-known cloud providers, their small print in the contract state that's actually disaster recovery is essentially your responsibility, which is sometimes a surprise to some. So the question is, could cloud be your disaster recovery? So I'd like to move the discussion around and focus on Gartner's prediction by 2014, which is not that far away, is 30% of mid-sized companies will have some form of implemented disaster recovery in the cloud. And indeed, I'm already seeing this in my client base in Australia, that for those that are concerned predominantly about moving their critical applications and infrastructure to the public cloud arena, that it does make eminent sense to essentially move their disaster recovery into the cloud because of the issue of scalability, etc. So at the end of the day, rigorously test any broad assertions that your critical production IT environment, your live environment, moving it to the cloud is the way forward. Cloud, unfortunately, has polarized the discussion for placing people generally into two camps, one of which is the evangelists, which really see cloud as absolutely inevitable, and those that are on the naysayers sitting on the fence say we're just not willing to go, the risk is too high. So basically, at the end of the day, if you have mission-critical information assets, it's really advisable that you should retain direct control of these critical information assets, and moreover, public cloud is not your only option. At the end of the day, it's your business at stake, not the providers. So server and virtualization has been around for quite some time, and that is the really power behind the infrastructure that powers the cloud. And in particular, this agility allows organizations to modify their disaster recovery strategies without any long-term capital requirements and investments. And obviously, that talks very well to organizations that are, and volatility is the norm in organizations and the commercial environments we all operate in, that the ability to adjust and move your goalposts, as it were, without having to necessarily lay down capital for your disaster recovery is a significant advantage. Scalability is one of the key things. But more importantly, a disaster recovery service provider oversubscription problems is a real fundamental challenge when it comes to conventional disaster recovery. You just hope that your disaster recovery, your traditional disaster recovery service provider doesn't have 20 clients all in the same suburb or jurisdiction or geography that is trying to knock on the door to initiate a disaster recovery. So cloud, through its inherent scalability, significantly eliminates that as a risk. It's in its own right. So the emergence of pay-as-you-go disaster recovery services allows you to scale up and scale down as and when needed in your particular disaster recovery scenario. So on that note, hopefully I've been able to cover off some of the key aspects and of the disaster recovery within a public cloud. And I'd be more than delighted to obviously take questions in the run of this session. Thanks very much.
Thank you, Rob. There are a number of points there that I'm sure may provoke questions from our listeners. So I want to remind them to enter those questions on the right side of the screen if they have any, and we'll answer them at the end of the presentation. Now I'll introduce the CEO of Quorum, Larry Lang. Larry, please begin.
Okay, let me get started with a bit of background about the company. We were originally part of technology for the defense arena, developed here in Silicon Valley, and are particularly focused on bringing this technology out to the middle America, the people who are doing the manufacturing, the engineering, and other sorts of design areas where perhaps the disasters don't involve incoming missiles, but are just as real for people, and we're very focused on those sorts of things. What I'd like to do is go through the requirements that we're seeing out in the marketplace and the economics of that, and then talk about new technologies that are making things possible. What we see is that in this digital world, people are more dependent on computers than they ever have been before. And we see this in all sorts of places. Now, it's obvious in some industries, for example, regional banks are key among our customers, but they definitely need their computers, as do law firms. What we find is even in manufacturing and industry and design and so forth, that people are dependent on these computers as well. And that comes up again and again in the discussions we're having, and that they just can't afford to have long periods of downtime. To offer some examples of that, one is a case study of a proactive entity, a company called Reno Refractories out of Alabama. What prompted them to take action was, as you're probably aware, in April of 2011, last year, there were some tornadoes that went through the Tuscaloosa area. And, you know, there's nothing like seeing invoices and other such business paperwork from your colleague businesses in the area come floating down in your backyard to make you realize you need to be taking steps to protect yourself against that kind of disaster. And so they've put in a system, and I'll be sharing more about what that system looked like, that allows them, that took their recovery time down from a couple of hours or days down to a couple minutes. Probably at least as important to them was the ability to test things regularly. Because as you're no doubt aware, one of the longest distances in technology is the distance between should work and does work, and the way to bridge that distance is through testing, and that's a big part of that. As an example of what happens when you don't have that, another entity, not our customer, but was certainly a very public case, was in New Orleans. And what's interesting about this was it was actually 5 years after Hurricane Katrina. You would think that that was the problem, but no, this was just a boring case of a failed server, burnt out motherboard or what have you. They thought they were taking backups to a cloud service, but because they weren't testing it regularly and had no way to test it regularly, they didn't realize that in fact the service had stopped receiving data earlier and in fact had no more records. So when they went to go enter this or to bring up their recovery system, in fact they had no data to restore, and in fact as a result they had to re-enter a great deal of data about the records of New Orleans real estate, and so for 3 or 4 months no one could buy, sell, or refinance anything in that area. And you'd be shocked to know it, but the political appointee managed to get by without losing her job. Unfortunately, the technical person wasn't so lucky and found herself out of work, even though she in fact had asked to get the budget required to do the new systems. That request had been denied, and yet she was the one left holding the bag. So sort of a shame there, but a lesson of why it makes sense to be more proactive. So a lot of research has been done in this area, some interesting statistics. A great many people have said that they can no longer afford even an hour or less of downtime. You see here a majority of people saying that they really can't afford that kind of downtime anymore. Another interesting statistic is we see people saying that their downtime could cost upwards of an average rather $74,000 an hour. Now this is going to vary for different people, but here's a simple way of computing it for your enterprise or your outfit. Keep in mind that in a typical year there's about 200 business days, not counting weekends and holidays and such, and in each business day there's about 8 business hours. Again, sort of a nominal figure. More of us find ourselves working longer hours, but it gives you a sense. So you multiply that out, that suggests that there's about 1,600 business hours in a year. So you can divide the revenue of your organization by 1,600 and get a quick rule of thumb of what an hour of downtime might cost, and however many thousands of dollars that might be. Of course, you have to keep in mind that that doesn't necessarily spread out evenly. For example, I talked to one accounting firm, and they said, well, that's sort of true, but of course if on April 14th, the day before the taxes are due, the computers went down, you could bet we'd be losing a lot more than the average amount. And so certainly that kind of thing makes sense to consider as well when those peaks of earning happen, or when there's a deadline where you're trying to get something produced for a customer. There may well be peaks where it could have an even greater impact, but still it's useful to have that rule of thumb, what an hour of downtime costs. The other thing, and I alluded to this earlier, was how infrequently, frankly, people are testing their backup, and that's a big issue for a lot of people. And they really are looking for ways of not just having quick uptime, but knowing they have quick uptime, and that really comes down to having the right kind of test plan in place. It's interesting to look at the economics of this, because historically there have really only been 2 places where you could go. You could look at a traditional backup system, and by that I mean backup to tape or backup to even disk, going off-site. And what you found was that this was pretty affordable and pretty typical of what we see. The most typical thing we'd see for our customers before we meet them would be they're using a product like Symantec Backup Exec, going to tape, say, and someone like Iron Mountain's taking those tapes away to hopefully somewhere safe each week. And that's not that expensive comparatively, but unfortunately takes days or even weeks if things don't go right to restore. Now the flip side is if you were running, say, the New York Stock Exchange, what you'd do is build multiple data centers and buy at least 2 of everything, probably 3 or 4 of everything, and spend a lot of money not just on all the duplicate stuff, but also on technology to synchronize those duplicates and a small army of people to keep it all running. And from our point of view, that created a gap in between where we wanted to come in with a situation where for the active business, where we could be back up in a couple of minutes without incurring all the expense of buying 2 of everything and so forth. And that was what we thought, and certainly our success with customers to date suggests we were right, that there was a real gap in the marketplace. of people who wanted to be able to recover in a matter of minutes and couldn't stand the hours and days of downtime, but needed to do that in a cost-effective way that was commensurate with those early figures that I talked about in terms of how the cost of the downtime. So what are the alternatives? Well, the most typical alternative that's installed right now is people taking backups of their servers. It might be 5, 10, or 20 Windows servers, maybe some Linux, putting that perhaps on a disk system, but eventually they want to get it off site, so they put it on tape, and they send that off to with Iron Mountain. Some cases less formal than that. Spoke with one customer who their plan was they put it in their trunk each night before they went home and hoped that that would work out. But one way or another, there's some issues with this. It's certainly going to take time to get that media back. It's going to take time to restore, and probably the worry for most people is that it takes time to test that, because you basically have to run that whole process in reverse, and that's easily going to take hours or days. If you're doing that even once a quarter, you're in good shape. As I mentioned, another alternative would be to have a replicated data center where you have, in fact, a whole second data center. But frankly, unless you're a very large enterprise, this is a little bit out of reach. It's not easy if you're running a manufacturing company or an engineering company to convince the business leadership there that every time you buy anything for technology, you should buy another one. It essentially doubles the cost, and then of course you'd have to incur the cost of systems to synchronize and people to run all that. So, makes sense if you're running the stock exchange. May not make sense if you're running a mid-sized business that doesn't have that kind of budget and that kind of time. Now, a lot of people are interested in cloud, and Rob did an excellent job of talking about the cloud for a variety of things. Of course, some of that's for applications, things like Salesforce.com or NetSuite. But one of the applications is to do backup. And certainly for personal machines, or even for small businesses, that kind of thing of just sort of straight cloud storage makes good sense. I recommend to sort of friends and family that they use the services like Mozy or Carbonite or Backblaze or Jungle Disk, any of these things to protect their computers, family photos and things like that. Those are great systems. The problem with them for businesses is that, the businesses often have a lot more data. Our typical customers might have somewhere between 3 and 5 terabytes of data. And if you do the arithmetic about how long it would take to download that from a cloud, that would take, perhaps a week or more. In practice, what people do then is call up and ask for shipment of physical media again. You're like, well, wait a second here. The reason I moved away from tapes and Iron Mountain was to avoid waiting for shipment of things, and that doesn't solve anything. So what's desirable is to take advantage of the cloud without having to worry about those kind of delays. In fact, you're trying to speed things up, not slow them down. In a sense, the way you can think about this is that traditional backup is obsolete. Traditional backup assumed that if a computer broke or that it was destroyed with a tornado or whatever, that you had no choice but to go to the old computer store, and you can tell this old-fashioned because it's black and white, get yourself a new computer, install it, and run the tapes. And the whole rhythm to that was going to take hours or days. But now, of course, that doesn't make sense. And why doesn't it make sense? Well, really for the emergence of two important technologies. One is cloud technology, which essentially allows you to purchase access to another data center and all the storage and compute there as a service. And that's why it's so interesting for disaster recovery. The other is virtualization, and I'm sure everybody on this call is familiar with the technology. The reason why virtualization is so interesting in a disaster recovery point of view is that it allows you to create a replica of your servers that are running your applications very quickly. You don't have to go to that computer store anymore. You can call up a recovery node very quickly, and that is why that is so important. So we really take two approaches to this. We always have an on-site appliance to help with this. And the reason for that is that a lot of disasters are not, in fact, tornadoes or hurricanes. They're just little things like a power supply burning out or a disk drive dying on a machine. And we find that having a copy of your data and your application and your server right there on site makes recovery much quicker because you can do it at land speed in the same subnets that everybody else is using. But of course, prudence dictates that you also want to have an off-site version, and our customers take two approaches to that. Some customers who are not comfortable with cloud simply put another appliance where we synchronize everything off to another location. Others go ahead and purchase that as a service because they prefer to be able to do that. And that makes sense as well for different customers. That's more of the hybrid cloud approach. The way this works is customers install that on-site appliance next to their servers on their premise, and those might contain, for example, order documents from the customers. We have customers who are keeping CAD files of designs or things like that online and available. And we put an appliance right there on those LAN segments next to those servers, and then another version off-site, and those two are constantly in synchronization. Then if something should go wrong, where one of those should die, you can see there it turned red, the IT person on the right there is able to quickly go into the appliance and bring up an exact replica of that SQL database or Exchange server or document store, whatever it is, and be able to be back up and running. That makes it very quick to recover. So rather than being a couple of hours or days as they restore from some backup system, with the recovery system, with one click they're back up and running in just a couple of minutes. It's also possible to be able to do that off-site, because what we're doing is taking a full snapshot of the servers, the operating system, the application, and the data, not just the data, creating a full virtual replica of that off-site, and then that allows the customer to have a quick recovery, which is a very nice thing for them to be able to do. What I stress here, and this is sort of a snapshot of the interface of the product and the system that we offer. You can see each of the servers that's protected has its own line there telling you what's going on, that it's being protected, and whether it's running in the production mode or with a recovery node. But what a lot of the customers really appreciate about this is not just the ability to bring it up in case of recovery, but also to be able to bring it up in a test mode. And we have customers who routinely use this mode of the system to be able to, for example, apply patches or upgrades to make sure that it's actually going to work in production, and not have to experiment with their production environment, know that it's going to work. And this allows them not just to recover from disasters, but to avoid them outright. As you can see here, this involves bringing together a lot of technology. Of course, backup and the replicated storage to keep those backups. To do this efficiently, we use deduplication. This is important both locally, but especially as we take the copy off-site. Virtualization is key because, in a sense, what we're doing here is not just automating backup, but automating restoration and recovery. We always have those ready to run, which is a form of P2V and V2V migration. Those are shorthand from physical to virtual or virtual to virtual. So whether you're using physical or virtual servers, we're in a position to protect those. In fact, most of our customers have a mixture of both. And then monitoring that, because one of the things that we do on behalf of the customers is monitor every single one of the nodes we have, both on-site and off-site in the cloud, so that we know and can tell the customer if we see any problems, much as you would want to monitor a fire suppression system or a burglary alarm system, any sort of system that's meant to keep you safe. Doesn't make much sense to just set it and then forget whether it works. You want to be able to monitor that all the time to make sure that it's ready to go, and that's a key part of the design of our system. So let me just sort of summarize where we're at here. For every kind of business now, IT is more important than ever. I spoke with one customer recently who was explaining that in the past, the main thing they did with computers was write bills for their customers. And you know, customers never call to complain that their bill is 2 or 3 days late. But increasingly, they use their computers for customer-facing activities. For example, in one case, the customers are uploading designs that they want fabricated in their system. Well, clearly, if the customer can't upload their design, you know, it's unacceptable for that to go on for 2 or 3 days, because after all, that's something the customer is trying to get done. And that was the sort of change in IT environment that was motivating them to look to go past a backup system and instead create a recovery system. And it's that change in IT environment that's motivating this. This new technology makes that possible, but it's all the technology together, the hybrid cloud capabilities, the virtualization so that you have the instant recovery node ready to run, deduplication so you can do this efficiently, and most of all, automation. What makes this all possible, and this is really the technology that came from the defense industry, is this ability to automate and orchestrate bringing this all together, because what we find is that you may not be under fire the way you would be in a military situation, but when things are going wrong, it sure can't feel that way. And using those same sort of automated recovery systems that were first pioneered in a defense situation can make a lot of sense, even in a business situation where an emergency is happening, things are going wrong, and you need to have an automated recovery plan. And finally, this needs to be dependable and ready to go. And what makes it dependable? Well, testing. And a huge step forward with these recovery systems that are in the cloud, that are based on automated recovery, on virtualization, is that rather than manually testing them maybe once a quarter, every single day we're bringing up that replica of your servers and your applications on-site and off-site and letting you know, yeah, not only do you have a backup, but you have the recovery system ready to go on-site or off-site. So at this point, it makes perfect sense to be able to test every single day. And as I mentioned earlier, it's really testing that can assure you that whatever systems you have in place are the things that make sense. So I'll finish up here with just a snapshot of our selection of our customers. You can see here that there's various banks, law firms, accountancies like you might expect, but also you can see there's a number of energy companies, electricity companies, manufacturing companies, in diverse industries, whether that's everything from paper to metalworking and so forth, a variety of customers. And what they all have in common is that they rely on their computer systems, on their applications, not just for their own billing and record keeping, but increasingly to create a customer experience in terms of taking orders, taking in designs, taking other requests, and being ready to go at a moment's notice. Great quote there from Wayne Bailey, the gentleman from Alabama, and how he's ready to go, and how this whole upgrade that he's put into his world is taking a lot of pressure off his mind, because he knows if something goes wrong, they're ready to go with a recovery system that'll take care of them. So that wraps up my section of the talk. I certainly thank you for your attention. I see that there's a good number of questions coming in. Hopefully we'll have a time to get to many of those. And with that, I'll turn it back to Robert to take us through that session.
Okay, thank you, Larry. Sorry about that. We've got a number of questions here that we want to proceed with. A few of you have already submitted your questions, and we're going to proceed to those. While our presenters are responding to the questions, I want to encourage everyone in the audience to please take a moment to answer the feedback form that will appear on your screen. If you have pop-up blocker technology, we ask that you disable it long enough to receive the form. Okay, the first question, Larry, do you provide a test of the entire environment, and if so, how often?
Right, so that's a good question, and as I said, we definitely stress testing. The short answer is yes, we bring up the entire environment. Now, in the automated tests, what we're doing is booting up, both on-site and off-site, what we call recovery nodes. Those are basically photocopies of your full server with the OS, the application, the database, whatever, and bringing that up and making sure that that boots up. And in fact, we boot up all of those and so forth. And that happens essentially every time we get an update. So that could happen every day or multiple times a day in some cases. Now, what we find is that oftentimes while that automated testing gives people a good sense that the baseline functionality is there, sometimes people want to do more testing than that, either for themselves or we have people who have to demonstrate to an auditor or someone else for that. So, for example, we had a customer who's in banking recently who had the FDIC come in, and the FDIC said, the examiner, as they call them there, said, please show us this environment. And there they brought it up, and they didn't just check that it came up. They actually were able to go into that test environment that's out of production and run in that case, loan transactions and check imaging and so forth, and make sure that that's right. So clearly, some of the testing, we're not going to automate running through loan transactions on the system. That's beyond what's in the automation. The automation makes sure that the systems come up, but it does create that environment where if you want to do more elaborate testing, you can do that. The other kind of testing that we actually think is the most important is not about the technology at all. It's about the human factors. What we find is that when people look at the cloud version of things in particular, now rather than say once a quarter, restoring from tape and running that kind of test, they know that part works because that's testing every day automatically. Instead, once a quarter, what they might do is to say, oh, what we're going to do is for example, ask everybody, assume, for example, that the firm, an architectural firm, say, was destroyed or, was otherwise not available. What we're going to do now is ask everybody to log into the Cloud Disaster Center and make sure it works. And you're running the fire drill, if you will, of that. So I'd say what's important here is that as the more mundane technical recovery part of things is being tested on automatically, it allows the IT leadership to start focusing on the human factors testing, which is where things often break down in the case of a real disaster. So hopefully that gives you a feel for all the different kinds of testing that become possible with this sort of system.
Very good. Here's a question that seems to be fairly important. Do you support Linux systems?
We are just introducing that now. We started with Windows because that was what we saw a lot in the customer base, and we support that all the way from Windows 2008 R2, and with the new Windows Server 8 coming out, that'll be supported. But at least as importantly to people is we go back in time as well. It's remarkable to me how many people are running things back in Windows 2003. We have a good customer in Ohio, for example, who is running a distribution business on Windows 2003. It works for them, and we recover that as well. But we did see an increasing number of people who also had some Linux systems as well. So in the version of software that actually is in beta right now, a couple of people already using it, and we should be rolling that out to general availability. That Linux backup system is being added now, and that should be a matter of days or maybe next week, as it turns out, that'll be available to the general public.
Oh, timely question then.
Yeah.
Do you provide archiving solutions?
Yeah, that's a really good question because let me take a step back. Our philosophy here is that we want to basically allow people to take what they're currently spending on backup and repurpose that budget for a system that provides recovery and testability as well. But of course, if we're going to do that, we need to be able to do everything that their backup system might have required. And of course, one of the reasons you take backups is for IT reasons, so that if your computers break or something goes wrong, you can recover your IT capabilities. But another reason, as this question alludes to, is for archiving solutions, is that it might be that a couple of years from now, for some reason, perhaps the IRS shows up, or perhaps there's a lawsuit or some other sort of thing, and you need to go back and look at your records as they appeared a couple of years ago and be able to do that. So the good news is that we have come up with a system that allows that. We allow people to archive their data either on-site or off-site or both. And what's neat about our system is we're, of course, not just archiving the data, we're archiving the entire environment. So that if you've upgraded your software, no problem, because we still have a copy of the way it used to work, and you can get at those records. Pretty routinely, we see people dimensioning their archiving systems to give them 7 years of archiving capability. That has a lot to do with IRS retention requirements and things like that. But yeah, that's definitely a part of it, and definitely engineered so that you can set up whatever archiving policy makes sense for your situation. Maybe if we have an architecture firm who concerns themselves with how long it's going to take to be able to in case some issue comes up with a design years later, they still have access to that, and they're in good shape with that. So yes, definitely archiving is a part of the solution that people add on and can retain it for years if you're concerned about that.
Okay, just a bit more here. Do you support Hyper-V?
Yeah, it's actually Hyper-V.
Hyper-V. I was afraid of that.
Yeah, no, there's
Sorry,
no
everyone.
jargon in this. There's no end of jargon in this world, and it's hard to keep up with it all. Yeah, so Hyper-V is the form of virtualization that Microsoft supports. The short answer is yes. The longer answer is that we support that, but we also have customers who are using VMware and customers who are using Xen, and also customers who are using physical servers. And I'd say what's most common is customers are using some mixture of all of those. So we have, for example, one customer in Australia, as it turns out, who is a combination of physical servers, Hyper-V servers, and VMware servers, and we're able to snapshot all of those, create recovery nodes of all of those, and bring those all aboard. Part of our design philosophy is that we want to meet the customers where they are. We don't want to start by telling them, oh, you have to virtualize everything, and in fact, you have to virtualize everything using VMware. You can't use our system. That's not our approach, because we know our customers are busy people. Our approach is exactly as your environment is, whatever hypervisor, whatever operating system, whatever application you have, we're going to just take a snapshot of that and allow you to keep running with the recovery node. So yes, we do support Hyper-V.
Excellent. I'm afraid we're running out of time here. On behalf of American Machinist, I want to thank everyone for participating in the webcast today. Thanks to our presenters. Rob, thanks for starting your day off early with us. Larry, thanks for all of the informative detail. Thanks to Quorum for sponsoring today's event. And to all, have a productive remainder of today.
Thank you very much.